Hello everyone, welcome back to the channel. Let's continue implementing the core module of our application. We're going to focus on the database of our application. Under local, I'm going to create two folders, one for the database and one for the entities. Let's define our database. It's going to be a class. Let's call it PocketGoods database context. It has to be public. This is the main database context for our application storage layer. This class will inherit from database context the entity framework core base class. Let's add the default constructor for this database context class that's going to be used when no options are injected. And let's overload the constructor for dependency injection or unit testing. This is going to allow external configuration, for example, in memory database that we have seen under the other applications. And we have to pass here the DB context options of type PocketGoods database context. Let's add here the options. Next, we have to define the database table represented by DB set of type T. Going to do that later on once we're going to define our entity. The first step that we have to do is to configure the database by overriding this protected method on configure database, and we have the DB context options builder. We're going to configure this database only if no options were passed. For example, in production mode. Therefore, we have to do if options builder is configured. If it's not configured, to configure here is the application cache folder. And we have to add here the path of our application. And we have to do it basically dynamically. In order to do so, I'm going to build a helper class that's going to take care of this particular task. Under util, I'm going to add here a new folder. I'm going to call it miscellaneous. Under miscellaneous, I'm going to provide the constant that will be used under this particular project for the table names, all the other constants that we have defined in the other apps. It's basically a class that's going to represent the tables of our database name, the application name, and the host base URL, and the token that we're going to secure later on. And for environment testing, I'm going just to add here this flag test under the test environments. I would like to proceed here in a generic manner. This class should be reusable, not only for this particular project, it's going to be helpful for other projects, if you will. This is basically the philosophy that I want to proceed with in all my projects, to be honest, and it helps me a lot, actually, because I don't have to reinvent the wheel every time. It's going to be a class, let's call it path helper. Let's make it a public static class. I would like to define a function that's going to help us to return the assembly path. The assembly path is going to help us to get the application folder where to store our database. Let's provide the generic type. First things first, we have to get the assembly containing the specified type by doing assembly equal type of T and assembly. All right. Next, we have to get the location of the assembly file. Let's call it assembly location. If the assembly location is empty, we're going to provide it dynamically by doing if string is null or empty. We have to provide as an argument the assembly location. In this case, we're going to generate the assembly location dynamically by doing assembly location equal new URI and assembly and location. And we have to access the local path. Next, we're going to return the directory containing the assembly by using path and get directory name. And we have to pass as an argument the assembly location. As simple as this. All right. In this particular class, I would like to get the dedicated folder where to store the database for caching. It's going to be a computer property. Let's name it cached folder. The cache folder as a value, the application data, and we have to pass the application name. We're going to combine those two values by doing path and combine. Yeah, it's correct. I think it's correct. Let's use this proposition. Environment, get folder path. Instead of this local application data, I'm gonna use application data. All right. And instead of this, let's not hard code this. It's gonna be just constant and application name. This is where to store the cache or the database. And I would like to create the application folder if it does not exist by this function. It's gonna be a static function as well. No return type. Let's call it ensure app folder. I'm trying to use the naming convention under C#. Let's provide the folder path. If this path does not exist, I'm gonna create this directory. That's pretty much it for this class. It's gonna be very handy Now let's come back to the Pocket Goods context. For the location of this database, we're going to use the path helper and cache folder. The next configuration that we have to do, we're going to make sure that the folder exists before creating the database by doing path helper and ensure app folder created. And you have to pass here as an argument the database path. Next, we're going to configure Entity Framework Core to use SQLite as the local database engine. And we have to enable lazy loading of related entities. We're going to do this by the options builder, and we're going to use basically the SQLite engine. We're going to provide here the data source equal from the path, and we have to combine basically the location of the database and the database name. And I highly suggest not hard coding this and combine basically those two values, database path and constant and database name. All right. And for the record, database name, let me hover on this, Pocket Goods database and DB. This is basically the database name. And that's pretty much it for the configuration of this particular database. Let me add this as a string, source equal, let's make it readable. Now it's time to define the entities. I'm going to get you up and running. If you're not familiar with entity framework, by creating this simple entity, which is app settings entity. Create initially a new class. Let's call it app settings entity. To create an entity under EF framework, first of all, we have to annotate this. Let's define here the table name, app settings table. All right. Has pretty much the ID, is dark mode, and the latest visited route. Let's create the first one, ID. It is a huge debate again for the naming convention of ID. I would like to use it like this. First of all, a key, and the column name, it is ID. If you ever were to open this database under SQLite Manager application in Windows, you have to see this column name as ID marked with this kind of convention. For this particular field, it shouldn't be auto-generated by doing database generated and database generated option none. The column name, gonna copy this, is dark mode, and we're gonna call it is dark mode. As simple as this is how we define entities under EF framework. Let's create the image entity, create a new file, and let's call it image entity. First of all, let's add the table name for the ID, which is the unique ID from Laravel. Key and required, and let's specify here the column name and the type of this column name. It's going to be a variable character of 200 characters as maximum length. Next, we have to define the file name, preview, and original. For the preview, it should be text, long enough to represent the URL. Likewise for the original. However, for the file name, let's specify here just 200 characters as maximum. Next, we have to define the model ID. For the model ID, it should be a foreign key, belongs to the product entity. So we can define the virtual computed property as the related parent entity. After defining the product entity, we're going to annotate or to specify this model ID as the foreign key that belongs to the entity product. So we can define the needed relationship. Under this table, I would like to specify that this particular model ID is an index. I'm going to add here a to-do, add foreign key constraint, and we have to add here the parent entity. It's going to be basically the product entity. Speaking of which, let's define the parent entity, which is product entity. And again, we're not going to cache the product preview. We're going to cache the detail of the preview. As usual, I would like to add the table name, and for the ID, it should be not auto-generated. And we have to define the title, category, and the price. For the price, it has to be decimal, and let's take only 2 digits, and the quantity is integer. And let's not forget about the description. For the title and category, I would like to add them as an index. So it's going to be very performant when looking for this particular title or category. Next, for the description, it is basically required as a multi-line text. And this particular product has lists of entities, which is the media collection. And again, the relationship between the products and images is one-to-many. We have to do public virtual I collection, which is one-to-many, which is basically a list of type image entity. Let's call it media as we have done in other apps. Get and set. For the initial value, it should be null. If you are confused about this kind of syntax, it means that this virtual collection is nullable. All right, I'm going to override toString for debugging purposes. The product entity is ready to go. Let's come back to the image entity and define the rest. We have some to-dos. As I said before, we need to add the foreign key that belongs to the product entity. And we have to add the parent entity. And the relationship here is an image belong to one product. Virtual product entity, product, and it is nullable. And this is how to define basically the relationship between two entities. All right, let's move on to the wishlist item entity. Let's customize the table name. We need to specify the ID, the product ID, and the user ID. And I would like to add the product ID as well as the user ID as index. Now we have here a relationship between wishlist item entity and user entity. Wishlist item entity belongs to the user entity, and the product entity belongs to wishlist item entity. Let's add here a to-do, add navigation property to user entity. Of course, if needed, which is nullable. This is pretty good. Next, going to define the other relationship, public virtual product entity of type product, get and set, which is nullable. And I would like to add here the string representation under toString. Now let's add the user entity. As usual, the table name, and we need to define the ID, which is not auto-generated, the name, the email, and the email verified at, which is date time. The email should be unique. Therefore, I'm going to add here index, name of email. In order not to hard code this, is unique equal true. And the user entity can own the list of wishlist items. Therefore, we have a relationship one-to-many by doing public virtual, which is good. The proposition and the autocomplete is awesome. I'm going to name it instead wishlist, and instead of this, it should be nullable. You can add toString, but it's not mandatory. Now let's come back to the wishlist item entity, and we have to add the navigation property user entity. It's going to be public virtual of type user entity. Let's name it user and null, which is correct. And that's pretty much it for the entities for our application. As you can see here, nothing complicated. It is very intuitive under entity framework. Now let's come back to the PocketGuts database context, and let's define the database table. The first table, public, as I said before, it's going to be represented by database set of type C, db set, user entity. Let's name it user entities, all right? Nullable. With the same manner, we're going to define product entities, app settings, image entities, and wishlist entities. If you do remember, under the Kotlin application, as well as the Swift application, we need to observe the changes, more specifically, the user data. Unfortunately, under Entity Framework, there is no such a thing as to observe in real time the changes. So it leads me to come up with some kind of workaround that's going to observe locally the changes of our database. The class that I'm about to create will provide a reactive wrapper around Entity Framework. It's basically the local view of type T, which is a collection of DB sets. Why the solution using only local view is not going to work? Because under Entity Framework, when we query entities, they are basically tracked in memory by the database context. Each database set of type T has its local property, local view of type T, that reflects basically all currently tracked entities of that type. However, the local view is not reactive. It doesn't notify whenever we have some changes under our database. In other words, it does not notify when the content change unless it's manually handled under the collection changes. The wrapper that we're going to implement, it's going to bridge the gap by turning the local view into an observable of type list of type T. A reactive stream of snapshots. It's basically the same role that we have seen under GRDB under Swift. And in Kotlin, you have just to use flow for that matter. Under database, I'm going to create a new class. I'm going to call it local observable. So just an overview of this class, how it's going to work. It's going to observe the local view that we have talked about earlier, more specifically, the collection changed event. Whenever the entity framework adds or remove items in the local view, we're going to take a fresh snapshot, which is a list of the current state. We're going to emit that snapshot to all the subscribers by calling a function that's going to see next, which is on next. It's going to serve purpose because it's going to reactively update UI or caches when entity framework data changes. And of course, we're going to combine multiple local data streams using Rx that we have downloaded as a package, which is reactive extension. We need to handle multiple data type. Therefore, we have to use here the generic type where this particular type a class. All right. First of all, we need to keep a reference to the entity framework local view collection. This represents all tracked entities currently loaded in the memory. So how to do that? We're going to update this collection automatically as queries load data, as we're going to query data, or when we're going to add or remove entities from context. If you do remember, we have something here like a DB set. So we're going to observe this. Let's pass the type T as a parameter, a local collection. This is going to reference the local view collection. Next, we're going to store the current observer. Basically, we need to store the observer so we can push snapshots or a single emission to this particular observer later. Like for example, to emit something to the observable. And how we're going to do this? When subscriber is going to call as observable, we're going to store the observer. So whenever we're going to emit a snapshot by calling on next or on error directly, this simple implementation only keeps one active observer at a time. We can enhance this later on in the future by handling multiple subscribers. But for this particular application, it's more than enough. I'm going to store here the observer under current observer, iObserver, iReadOnly list of type T that's going to contain the snapshots, current observer. Let's provide a constructor for this class. We need to inject the local view of type T that we want to observe. All right. It's going to allow this class to be reusable for any entity type. In our case, user, wishlist, product, it doesn't matter. I don't know if the suggestion got it right. So it's going to be local view of type T. Basically, what we have to do instead, if the local collection equal local collection, which is nullable, by the way, if it's not null, we're going to assign it. Otherwise, we're going to throw here an exception, new argument, null exception, and we have to pass here the name of this particular local collection. We can use named parameter for the constructor. That's what Visual Studio is suggesting here. In my opinion, we have to use primary constructor as suggested here. I think it's way better. Next, we're going to convert the local view of type T into an observable data stream that's going to allow the UI or any logic layer to subscribe and react to the entity framework core changes. I'm going to call this public function iObservable iReadOnly of type T. Let's call this function as observable. How to implement basically this function? We have to create the observable by calling observable and create from the system reactive package to build a custom observable. This is a custom observable sequence. We're going to subscribe to this observable. We have to save the observable and we have to hook into the local view collection change event. I'm going to emit an initial snapshot immediately and subscribe for the cleanup. We are using iReadOnly list because when we're going to emit snapshots as iReadOnly list of type T, we're going to prevent accidental mutation, which is very important. The mutation can occur under entity framework core tracked data outside of the context. So as I said before, we're going to create a custom observable and create for the type here is of type iReadOnly list of type T. Let's add here a parameter observer. First things first, we need to save the observer for the future emission by calling current observer equal observer. Next, we have to create a handler that's going to react whenever the entity framework triggers a collection changed event. Why? Because entity framework will raise this whenever the local view changes. In other words, whenever we have added or deleted some data using entity framework, it's going to change or to trigger the event. This handler is of type notify collection changed event handler. We don't care about the parameters. We're going to emit a snapshot here. Let's call this function emit snapshot. Underneath this, a public function, or you can just call it emit, whatever you want. This function emit snapshot is going to push the latest state of the local view of type T to the observer. It can be called anywhere in our application. How we're going to implement this? We're going to call local collection to list in order to take a safe snapshot of all the currently tracked entities, and it will send the snapshot to the current observer. Why we have to use here to list? Because under entity framework, the local view is live and mutable. If we expose this value directly, the external code could mutate while entity framework is updating, causing concurrency issues. By converting it to list, we're going to create a stable, independent copy. This whole section can trigger an exception. We have to take a snapshot of all current tracked entities. Let's store this under snapshot. It's correct from the suggestion. Next, we have to notify the subscriber, if one exists, with the new snapshot by doing current observer on next, which is correct. Visual Studio is following along. If we have an error, for example, the context has been disposed or concurrency issue, we're going to call here on error, and we have to pass the exception as an argument. Basically, it's going to forward the error to the observer. In the handler, we have to call emit snapshot. This will immediately emit an initial snapshot right away. We are basically done. Now we have just to handle the cleanup. Underneath, we're going to do here return. We are right now under the Lambda. It's going to be executed whenever the subscription is disposed. In this particular section, we need to remove the event handler and clear the observer reference to avoid any memory leaks. Basically, by doing local collection and collection changed, and we have to remove the handler by doing minus and equal, all right? And current observer equal null. And we have handled correctly the cleanup section. We have forgot one important thing here is to subscribe to the collection changes. Underneath this, as shown here by Visual Studio, we have to subscribe using the handler. After subscribing, we have to immediately, as I said before, emit a snapshot. Let's add this emit snapshot. And that's all for the implementation of local observable. We need to use this local observable under the Pocket Goods database. In this section, we need to keep track of the changes of the user entity to create the stream of data to observe real-time changes of the user entity as well as the application settings. Therefore, I'm going to create a private backend field for user observable of type local observable of type user entity, which is nullable. Let's call it user observable. This is going to be used for observing real-time changes in user entities. All right. Now we have to expose wrapper around the user entities database set. It's going to be lazily initialized. In other words, it's going to be created only when first accessed. It's going to be public local observable of type user entity. Let's call it user observable. We're going to use the user observable local observable of type user entity from the constructor that we have done earlier. And we have to pass here user entities and local. Then we're going to return user observable. With the same manner, we're going to add a backend field for application settings entity. We're going to expose the observable application settings observable and the public observable. Let's call it application settings observable. And now we can implement the stream user that we have implemented under Swift as well as stream application settings. But before that, I would like to add some utility functions under the Pocket Good database context for some crude operations. The first one, we're going to build a query that's going to include user with its dedicated wishlist. And for the wishlist item, it has the product and each product has media. This query is going to help us to define the relationship to load all related data in one go of type iIncludable, queryable of type user entity, and iCollection of type image entity. Let's name it to user data queryable. We have to do return and user entities. It has a resemblance to GRDB. We have to include the user represented by this parameter. Let's call it user, all right, and wishlist. Then we're gonna include, and the order here is very important, wishlist item. So now you get the idea. I'm gonna name it to uniform wishlist item and product. We're gonna include the product. Then we're gonna include another one, which is, and again, it is a 3 deep level relationship, the product, and we have to include the related media. This is a reusable query stored under user data query. All right. In order to implement stream user and stream application settings, therefore, I'm going to add here a to-do. After this, we need to implement basically stream user and stream application settings. I'm going to add another function for this database that's going to force the user observable to re-emit the latest snapshots of users, which is very important. We're going to use this under the implementation of the authentication repository. It's going to be user observable and emit snapshots. Likewise, for application settings, we're going to force the application setting observable to re-emit the latest snapshots of the settings. I would like to add here one last function that's going to be generic for creating or updating an entity. Let's get inspired by Laravel and create this function. It is an async function to return a task, create or update. We have to pass here t of type entity. As parameters, we need db sets of type entity. Next, we're going to define the callback function that's going to decide whether to create a new record or update an existing record. By using function, the first parameter of this particular callback function is entity and a task of type entity, which is nullable. Let's name it find existing entity asynchronously. Let's add a where statement for this type. The t entity should be of type class. We're going to store the return value by calling the function find existing entity asynchronously. Let's store it under entity, and we need to pass here the new entity. Let's add it here as a parameter, entity of type new entity, and let's assign it here as an argument. If it exists, to avoid tracking conflicts, we need to copy all the current values safely by doing entry, and we have to pass here existing entity and current values and set values new entity. Otherwise, we're going to, if the entity is not found, we're going to insert the entity. And that's pretty much it for create or update. I think that we're going to stop here. For the next video, we're going to continue this section of our database to define basically the rest. I hope you have learned something new. See you in the next one, and happy coding.